Hello students, welcome back to another session. In this video, this is in continuation with the previous parts. This is video number 9. I wish all the students will go through the previous 8 parts before going ahead in this part. And in this part 9, straight away, we are going to deal with the derivations of kinematic equations by graphical method. We have already seen the kinematic equations, right? 3 kinematic equations for 2 different cases, horizontal and vertical motion. Accordingly, those equations, what those equations are? V is equals to u plus at, s is equals to ut plus half at square, v square minus u square is equal to 2as, and you should know every term in that what it says. We already dealt all that, right? So accordingly, now we are going to talk about how these equations are going to be derived by using graphical method. What is graphical method? Making use of a graph. Graphical method involves we should make use of a graph to understand. Now, what are graphs? Actually, in one dimension motion, we have 3 important categories of graphs or 3 important types of graphs. That is called as ST graph, that is position time graph or displacement time graph, velocity time graph, acceleration time graph. In all these cases, acceleration, velocity and position or displacement is taken along the y-axis, and along x-axis we take the concept of time. And you should have some basic knowledge on these factors, on these 3 graphs. Most importantly, a student should know 2 things about each of this graph, like what that slope of this graph indicates and what the area of that graph gives. What do we mean by slope? Slope means y coordinate by x coordinate. We have seen slope of this line is given by for change of position by change of time, which results slope of this graph gives. Slope of any graph gives y coordinate by x coordinate. Slope of this graph gives velocity. Velocity slope is displacement by time, change of position by time gives rise to velocity. Slope of this graph gives what? Slope of VT graph gives acceleration, because velocity change by time change. A is equals to, by definition, A is equals to velocity by time. So slope of this gives. And one more graph called as acceleration time graphs. We have not seen much on this one, but if at all a graph comes like this, AT graph, like whatever it is, slope gives A by T, and there is no such parameter existing in the form of A by T. Acceleration by time. It will not give as to, there is no one particular parameter defined. It can be regarded as acceleration by time itself. No new parameter defined by this. Along with the slopes of these 3 graphs, you should also know what the area of this graph gives. What do you mean by area? Area means the total path enclosed inside this region. Now, if I enclose this part here, or if I take the coordinate axis of y, action like this. Now, area means the total region present inside this is called as area. What this area gives rise to, for that also will get area, for that also will get area. Total. If you want to find area of this, close this and draw the line, shaded part inside this. Now if you draw like this, and the shaded part now indicates the area inside this. What this area gives rise to? Area of ST graph gives rise to. Area means its y coordinate, like if you have some different rectangle or some kind of a square like this. Area means what? Side into length into breadth. Accordingly, area means what? Y coordinate multiplied by x coordinate. And here it is what? Here y coordinate is displacement and position, and time coordinate, x coordinate is time. Is displacement into time. Again, there is no such parameter exists. It is only displacement into time itself. No such thing exists. Now in this case, area of this graph gives rise to what? Area of this graph gives rise to velocity into time. Velocity into time gives rise to what? Because velocity is equals to displacement by time. If you take time to the other end, displacement is equals to velocity into time. Accordingly, area of VT graph gives rise to displacement. And area of this is what? Area is length into breadth, that is acceleration into time. Acceleration into time gives rise to what? Because acceleration is equals to velocity by time. If you reverse this one, if you take this one here, acceleration to time is equals to velocity. You should remember these 6 points: slope and area of ST graph, slope and area of VT graph, slope and area of AT graph. What I mean, just final recall. What is the slope of ST graph gives rise to? Slope of ST graph gives rise to velocity. Slope of velocity time graph gives rise to what? Slope of velocity time gives rise to acceleration. Whereas area of AT graph is what? Area of AT graph is equals to velocity. Area of VT graph is equals to what? Displacement. Whereas area of this one is equals to what? Area of this is undefined, and slope of this is undefined. These 6 important points you should remember. area, slope of three different graphs. A student must be well versed. We should be understanding. With this basic information, we now go ahead with the important part as kinematic equations of graphical, deriving kinematic equations by using graphical method. So check this part now. To derive these equations, we now I have written the entire explanation on the board here. You can check this. I'm going to read out this for you. Consider a body moving with an initial velocity u at a time of t is equals to 0. In a time of t seconds, let it acquires a final velocity given by means of v. As it covers a displacement of s, also it covers a displacement of s with constant, because our constant acceleration a. Our equations are meant for what? Constant and uniform acceleration only. So constant acceleration is given by means of a. This graph, this thing can be shown in the form of a graph like this. What is it in the graph? Try to understand now. At a time of t is equals to 0, body is having an initial velocity. It is not starting from rest. If it starts from rest, the graph would have been taken like this. But at the time of t is equals to 0, body already has some initial velocity u. After some time of t is equals to t, body is acquiring some final velocity of v. If you extend this graph, this is v axis, this is time axis. After some time of t, it is having, if you draw a dotted line onto this one, this is the value of velocity. This is a vt graph. We show, because we want to do this for constant acceleration, we take vt graph for this. So from this vt graph, we have line like this. And by making use of this vt graph with the basic principles, what the basic things what you have seen in the previous case, we are now going to derive the kinematic equations. There is a body moving in velocity u and various parameters are being changing. That can be shown in the form of a graph like this. Right? Now, to derive this one, to derive the first equation, first let us understand the various terminologies here. This is final velocity. This point is final velocity correspondingly, and this point is what? Initial velocity denoted by means of u, and this indicates the change of velocity, which is equals to v minus u. Now what is it? You can write the slope of this one. If theta is slope here, slope is equals to tan theta is equals to, it is y coordinate by x coordinate, that is delta v by delta t. This is what delta t is: initial t, final t, t minus 0 is delta t. And what is that we know from vt graph? Slope of vt graph gives, remember that I told you the points. Acceleration a, therefore slope is equals to acceleration, a is equals to delta v by delta t. This is equals to v minus u by t minus 0. V minus u by t minus 0. By rearranging the terms, you can write like this: a is equals to v minus u by t, or at is equals to v minus u. If you take u to the other end, v is equals to u plus at. We are getting this equation for this kind of a graph like this. This is the meaning of what? First kinematic equation. First kinematic equation can be shown by using a simpler graph or a graph like this. V is equals to u plus at is the first kinematic equation. Simple thing it is. Just you need to find the slope of this line, which is shown in the form of vt graph. Slope is equals to opposite by adjacent, or tan theta is equals to y coordinate by x coordinate. Y coordinates is change of velocity, x coordinate is change of time, that is v minus u by t. With the slope of this curve already use slope acceleration, we know a is equals to v minus u by t. By rearranging the terms, you are going to get the first equation called as v is equals to u plus at. Now, after first equation of v is equals to u plus at, we need to derive the second equation given by means of what? S is equals to ut plus half at. Where S is talking about what? Displacement. Accordingly, if you remember that vt graph, the area of a vt graph gives raised to displacement. Now we need to find the area. The same graph this is taken earlier there. I just shifted here to make use of the larger part of the board. Accordingly, we should know this is again a vt graph. This is again a vt graph. In this case of vt graph, the same things exist here. We need to now determine the area enclosed inside this region to get what? The second kind of kinematic equation. That is, to find the area, I'll first give some naming convention to this. O, let me call this point as A, let me call this point as B, and if you draw a line like this, this point C, let this be D. There are two regions in this. There are two regions present inside this one, and you should also know that change here, the velocity change is u, here the time is t, here also time is t, here the velocity change is u, here the velocity change is what? Here it is u and v. This is v minus u. Accordingly, you should know all this. Now, let us consider area of this. Consider area of what? Total part present in this. This total part can be now divided into two regions like this, and one more region is existing in a form like this. There are two regions inside this part. There are two regions inside this. Consider the area of OA. Total area is OA, B, C, D. OA, B, C, D. The area inside this is going to be this part. Or you can conclude this closed figure. It is in the form of O, A, B, C, D, O. The total region inside this is given by means of these parts. Total area is equals to, total area inside this is equals to, how can you find total area of this? Since there are two regions in this, area of this part plus area of this part. That is area of triangle. First one is triangle, which is given by ABC, plus area of rectangle, area of triangle ABC, and area of rectangle OACD. Check out this part. Total area is equals to area of this first region and area of the second region. First region is a triangle given by means of, in fact, right angle triangle given by means of what? ABC. Why it is right angle triangle? Because here the angle is 90 degrees. And this area is covered by triangle. And one more part is what? Rectangle. Some other area is enclosed here. That rectangle is given by means of what? OACD. So total area of this entire region is equals to total area of shaded region. Total area of shaded region is equals to area of this triangle plus area of this rectangle. Now we should apply some kind of mathematical formulas what we know for triangles and rectangles. Like total area right here. Total area of the shaded region is equals to RHS is equals to area of triangle. What is the area of triangle? It is half into base into height. If you remember the formula of a right angle triangle or triangle, it is half into base into height. What is base here? Base is AC and height is BC. Half into base into height, half into base is AC, height is BC. Plus, what is the area of a rectangle? Length into breadth. Here, length can be taken as out of OACD, length can be taken as OA, and breadth is taken in the form of what? AC. Length into breadth. This is equals to total area is equals to total area gives rise to what? Total area of VT graph gives rise to displacement S, which is equals to total area gives rise to displacement. You have seen the properties of this one. This is equals to half into what is that base now? Base is time into BC is equals to V minus U. BC is equals to V minus U plus OA into AC. OA is equals to what again? OA is equals to U into AC is again T itself. Just I am using the terminology present here. OA value is equals to from here to here, same as that of CD, which is equals to how much? Velocity U. OA is equals to initial velocity U. And AC is equals to what? Here to here, time factor it is into. Now we solve this further. S is equals to half times of T into V minus U plus U times of T. We now modify this from equation 1. From equation 1, we have that V is equals to U plus AT. You can now replace this V minus U by some other term. If you take U to this side, it becomes what? V minus U is equals to AT. Substituting this in the above equation, let us call this as A, let us call this as B. Substituting B in A. Substituting B in A, you can now say that S is equals to half times of T times of V minus U can be replaced by AT plus UT is as it is. Half into A into T into T. You can write this as S is equals to, I am writing this term first, UT plus half into AT into T is AT square. This is the equation what is needed for us. Second kinematic equation by graphical method. Only knowing how to apply the graphs and finding that areas of triangles and rectangles, we can solve this like this. Let me take a while to erase this board. You can go through this, pause the video and check that steps. I know I'm repeating the videos. What happened? It become lengthier. I'm not repeating. Just you pause the video and go back and check again. Now to find the third equation, we make use of the same equations again in a different form. What is the third equation? V square minus U square is equals to 2AS. You should eliminate time factor. Now there are various set of equations I come across here. Like in this equation, I can say from straight away from equation A, you need to eliminate time from this. If you try to, because in third equation there is no time factor. Accordingly, you should now check to how to eliminate time from this. To eliminate time, you can make use of this equation from B. That is, time is equals to V minus from B. From B, you can write that time is equals to V minus U by A. Now what we do is that we replace this equation time in this A, substituting this equation in A, you are going to replace time by means of velocity, acceleration. Now all the things what are needed for us are going to be connected. And we solve this by substituting, let me say this as C. Substituting C in A, you are going to solve the third kind of V square minus U square is equals to 2AS. To do that one, in that equation of V square minus U square is equal to 2AS, there is no time factor. So time has to be removed from this equation. You make use of the same equation. Time has to be removed. To remove time, what is that we are going to do? We are modifying this equation B like this. From B, you can say that time is equals to, from B, time is equals to V minus U by A. By substituting time in this, you are going to eliminate T from this. Accordingly, substituting C in A, you are going to get eliminated T factors. Once you solve that, you are going to get the third equation. It is like this. Substituting C in A. Now check out what you are going to get. S is equals to half times of V minus U. This V minus 2 is as it is, and for this T I am going to write what? V minus U by A. Half V minus U is as it is. One T has replaced by V minus U by A plus U into, again T is replaced by V minus U by A. V is replaced by T minus U by A. Accordingly, I can now eliminate this part. And let us check how to continue this equation. Right. What is it? You can take common U, V minus U, V minus U, V minus U, and here you can take V minus U by. These three are one terms. This is one term with a plus sign here. That is, S is equals to, if you take V minus U by A common, if you take V minus U by A common, it is left with half V minus U plus U, I suppose. V minus U by is taken common and it is left with U. Now simplify this further. S is equals to V minus U by A times of, if you take multiplication, this, if you take cross multiplication of these two things, this is V minus U plus 2U by 2 whole divided by 2. I'm just cross multiplying. 1 into V minus U is as it is, 2 into U as it is, divided by 2 into 1 is 2. This is 2U plus 2 U it is. Extending further, S is equals to V minus U by A. 2 can also be taken to this side because both are multiplying, and left with what factor? V minus U plus V minus U plus 2U. What is that? V minus U plus 2U. You can write this as S is equals to V minus U by 2A times of minus U plus 2U is equals to V plus U. This is clearly in the form of A plus B into A minus B. These two are in the form of what? V minus U into V plus U, A plus B into A minus B gives us what? A square minus U square a square minus b square by 2a. Rearranging the terms, you are going to get what? 2as is equals to v square minus u square. That is, final equation is v square is equals to u square plus 2a. Yes. This is the way how we derive the three kinematic equations using graphical method. The three kinematic equations can be derived by using graphical method like this. Just go through the videos again and again if you are not getting any, if you have any difficulty understanding the things, and when I'm writing some kind of system format like this, you can just listen to that voice what it is giving rise to. Accordingly, you can correct that. It is in this way. So this is the end of what? The graphical representation of